So today we are going to discuss OCR. It's A-level chemistry H432. So topic number one is oxygen has the electronic configuration 1s2, 2s2, 2p4. How are the electrons in an atom of oxygen arranged in the p orbital? So regarding this, you must know how we are supposed to write down the electronic configuration. You know, if we have a p orbital like that. Okay, so let's say oxygen is 2p4. I have four electrons, right? So I have to fill these four electrons in a p orbital. So I'm supposed to fill in this manner. One, then two, then three. First of all, you are supposed to singly filled and then you are supposed to start in a double manner. Okay, so this is the correct way. If you will be filling the p orbital in this way, so this is completely wrong. So the rule says, first of all, you have to fill the orbital in a single manner, like single, single, single. And then if you have more electrons, then you have to start in a double manner. Okay. So this is completely wrong. This is completely wrong. It's against the rule. Sorry. Yeah, this is against the rule. Again, they have filled this orbital in a double manner already. This is wrong. First of all, we have to fill the orbital in a single manner, okay? So this is wrong. Why this is wrong? Because remember, whenever we have more than one electron in the same orbital in the same box, so the electron should be in this manner, upward and downward, okay? So this is wrong. This is right. So option D is correct. Okay, good. So I'm supposed to say water has the anomalous properties below. Water has relatively high melting and boiling point. Yeah, because it has hydrogen bonding. Ice is less dense than water. Which statement explains these anomalous properties? So the covalent bonding within the water molecule. No, 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 no. Melting and boiling point is not depending on the covalent bond. It is depending upon the intermolecular force of attraction. This is wrong. Then they are saying the hydrogen bonding between the water molecule. Yeah, this is correct. This is correct. Because hydrogen bonding is a type of intermolecular force. Okay, so melting and boiling point is a physical property, and physical property is depending upon the IMF, and hydrogen bonding is a type of IMF. Okay, so and then why C is not correct? The induced dipole-dipole interactions between the water molecule. Water is a polar. Water is a polar. It must have permanent dipole. It doesn't have ID force. Okay. It's a polar one. The ionic bonding, oh my God. Ionic bonding is the bond which is present between the metal and non-metal, and it's the intramolecular. Like it's, I can say if I have two water molecules, so I'm talking about the bond which is present between the two molecules. Intermolecular, not intramolecular. And by the way, water is not an ionic compound, it's a covalent. So D is wrong. Okay. Then question three, which chemical process is the most sustainable in terms of the atom economy of the iron produced? So, first of all, how can we find out the atom economy of iron? So let's say 2Fe divided by Fe2O3 plus 3CO. This is for option A, right? And for B, I can say 2Fe divided by Fe2O3 plus 3C, sorry, plus 3H2. Right, this is for option B, okay? For option C, 4Fe divided by 2Fe2O3. And then for D for doctor, I can say 4Fe divided by Fe2O3 2 plus 3 carbon. So they are saying which chemical process is the most sustainable in terms of the atom economy of the iron produced. So, when I would be putting the molecular masses after looking at the periodic table, so what's the formula to find out the atom economy? mass of the desired substance, that is in this case the desired substance is iron, okay, and also divided by the total mass of the reactant, total mass of the reactant, okay. So in this, carbon dioxide is a byproduct, in this water is a byproduct, in this oxygen is a byproduct, right? So it's a thermal decomposition, by the way, and also in this carbon dioxide is a byproduct. So as you can see, uh, this is a water, this is a water. So what's the molecular mass of water? Only 18. It's 18. Okay, so the waste, this is the waste, as the molecular mass is lower. If you talk about this one, it's 44. If you talk about this one, it's 32, like it's 32. If you talk about this one, it's 44. Water is 18. It's the lighter one. So that's why this is going to be correct. So B for ball is correct. But by the way, you must know what's the formula to find out the atom economy. Okay, if they would be asking to calculate the atom economy, so we can do like that. Right? Okay. Then which compounds of magnesium can be used as antacids? Which compounds of magnesium can be used as antacids? So remember, compounds of magnesium, it means that antacid, like anti-acid, it should be a base. Anti-acid, it should be a base. So magnesium chloride is the salt, it's not a base, it's wrong. Magnesium hydroxide is a base, yeah, this is correct. Magnesium nitrate is not a base, it's the salt, it's wrong. Magnesium sulfate, it's not a base, it's a salt, so it's wrong. So finally option B is correct. Okay, which statement explains the trend in the boiling points down the halogens group, like they're talking about group 7, right? So for the group 7, the bond enthalpy of the covalent bond increases. Again, I would say melting and boiling point is the physical behavior, is it's depending upon the IMF, the intermolecular force of attraction, right? Like between the chlorine molecule, between the bromine, right? So between the fluorine and fluorine, so I'm talking about the force which is present between the molecules, not inside the molecule. Like it's not like that. Whenever we boil the halogens, so this bond is going to break down. It's a covalent bond, remember. Okay, so let's say if I have solid sodium, if I'm going to heat it, so the solid iodine, sorry, not sodium, solid iodine. So if I'm going to heat it, so the iodine will be converting from solid to gas. Let's say, what's the formula for iodine gas? You will say I2, isn't it? You will say I2. If I ask, what's the formula for iodine solid? You will say I2. I2 is same. So if you have heated it, so what happened? Of course, the force of attraction between the iodine molecule weakens, right? So again, I'm saying it's depending upon the intermolecular force of attraction. So remember, it's not about the bond enthalpy. Okay, A for apple is wrong. Then I have to see B. The halogens become less electronegative. The halogen become less electronegative. No, it's not correct, because boiling and melting point, again I am saying, is the cause of IMF. B for ball is wrong. Then I have to see C. Induced dipole-dipole interaction become stronger. The concept says the ID force is directly proportional to the number of electron. If the number of electron increases, so the ID force increases. If the number of electron decreases, so the ID decreases. As we know, as we go down the group, it's fluorine, then chlorine, then bromine, then iodine, then astatine. Fluorine is 9, chlorine is 17, bromine is 35, I think so. I don't know for iodine. We have to see the periodic table. As you know, as we go down the group, the number of electron increases. ID force becomes stronger. More energy would be needed to overcome the force of attraction. That's the reason the melting and boiling point increases down the group. I'm talking about halogens. So, yeah, C for cat is correct, isn't it? Reactivity is something else, melting point is something else. They are irrelevant. Before going to do these questions, you must memorize, you must know each and every single concept regarding the reactivity, regarding the melting point, regarding the solidity, density, electronegativity, so that you can like do these type of questions without any hesitation. Okay, by the way, this is very easy. Which equation does not represent a disproportion? What is disproportionation? The reaction in which at the same time reduction and oxidation takes place. So this is zero. Before going to do this question, you must be very good at to find out the oxidation number. If you don't know about how to find the oxidation number, do not waste your time to do this question. First of all, I have recorded it. You can see, you can search how to find out the oxidation number. You will find my videos. You can see over there. After looking at those lectures, then you can do this question. You know why? Because I know the oxidation number for Cl2 is 0. It's going to be plus 1. It's going to be minus 1. It's going to be 0. It's going to be plus 1. It's going to be minus 1. It's going to be plus 5. It's going to be minus 1. It's going to be plus 7. Okay, it's going to be minus 1, it's going to be minus 1, it's going to be 0. It's the disproportionation reaction. At the same time, oxidation and reduction takes place. Why and how? 0 to plus 1 is oxidation, 0 to minus 1 is reduction. So yeah, this is a disproportionation. But they are asking which equation does not represent a disproportionation reaction. So this is a disproportionation, right? This is a disproportionation. Again, B for ball is wrong. Okay. And then 5 to minus 1, the number decreases. It's reduction. The number increases. It's oxidation. Yeah, D for doctor is correct. D for doctor is correct. It's not a disproportionation reaction. Okay. The equation for the reaction of sulfuric acid with potassium hydroxide is shown below. 25 centimeter cube of 1 mole per decimeter cube is reacted with excess KOH. The energy given out is 2.8 kilojoules per mole. So first of all, I need to find out the moles. So 25 multiplied by 1.00 divided by 1000. What I'm doing, I'm going to find out the moles. Mole is equal to concentration multiplied by volume. Concentration is 1.00. Volume is 25. So I have to convert the volume in centimeter cube into decimeter cube. I'm going to divide it by 1000 and I'm going to multiply this by 1. I'm getting 0.025 mole. Okay, 0.025 mole. So 0.025 mole contains this much energy. How much energy would be there if I have 1 mole? Because they are asking per mole. Kj per mole. Per mole means what? 1 mole. So I have to cross multiply this. Then I would be getting the answer. So let's say 2.8 divided by 0.025. It's 112. So C for cat is correct. Right. Okay. Which law in the table explains how a catalyst affects the activation energy and the proportion of the molecule with energy greater than? Number one thing is that activation energy decreases. Decreases. I have the two options, A for apple and B for ball. Okay, it's confirmed, it's 100%. So after adding a catalyst, activation energy decreases. It's gonna be A, it's gonna be B, because in C and D they are saying increases, which is completely wrong. Proportion of molecules with energy greater than activation energy. Remember, when the activation energy will decrease, now we have more molecules which have energy which is greater than the activation energy, which are going to do a chemical reaction. So the reaction becomes faster. So means B for ball is correct. Okay, simple. It's a very simple question, right? A graph of ln k is plotted against 1 by t for a reaction. The gradient has the numerical value of -16000. What is the activation energy in kJ per mole for this reaction? Okay, so okay.